organization. Our mission is to empower voters and defend democracy. We encourage informed and active participation with government, and we do that work in a nonpartisan manner, meaning we never support or oppose a political party or candidate. We help voters register and learn about upcoming elections on our voter resource, our online voter resource, vote411.org. And if you go there now, it has information on the April 6th election. You can see what's on your ballot, and you can compare responses from candidates to the questions we've posed. We also study issues and advocate for government policies that serve the public interest. And we present educational public issues forums like tonight's program. If you have questions during the program, please put them in the chat. And to get our program underway, I'd like to introduce Carol Diggleman, who is co-chair of the League's Natural Resources Committee. Thank you.
Thank you, Peggy. Welcome to our program tonight, where we will be hearing from both Kevin Shafer, the Executive Director of Milwaukee Metropolitan Sewage District, and Sandra McLellan, a professor in the Freshwater Sciences Department at UW-M. And we're very pleased to have both of them on our program tonight. Before I introduce Kevin, I'd like to introduce MMSD and a little of the MMSD history. The 1919 primary wastewater treatment plant at Jones Island was one of the first of its kind in the country when the original activated sludge plant was added in 2025. The 1925 plant was designated as a National Historic Civil Engineering Landmark in 1974 by the American Society of Civil Engineers. MMSD was the first to market biosolids created through the process as a fertilizer under the name millworgonite, which we're all familiar with. Kevin Shafer became executive director in 2002. He has been providing regional leadership in implementing gray and green infrastructure in MMSD facilities and around Milwaukee, and we'll hear about that tonight. He's responsible for planning, design, construction, and oversight of the operations for one of the leading wastewater utilities in the country. Under his strong leadership, MMSD continues its tradition of innovation. We welcome Kevin Shafer.
Good evening, everyone. As they're bringing up my slides, I see that one of my former commissioners, Candace Alley, is on the call tonight or on this meeting. So hello, Commissioner. It's very nice to virtually see you. It's been a while since I've presented to this group. I think the last time was with Dr. Rebecca Clapper from the School of Freshwater Sciences. So it's quite an honor to continue to talk about good science with Dr. McLellan here tonight as well. If you could bring up my slides.
Sorry, I'm having a little difficulty here.
As you heard, I've been executive director since 2002. Actually, last Thursday, a week ago, was my 19-year anniversary in this position. Sandra and I have been working together that whole time, I think, and it's been an honor.
Yeah, we have. When Carol said 2002, I said, wow, Kevin, we have a long history.
We don't get to see much of each other right now, so that's too bad.
Right. I think it's been I think it's this last year has really kind of short-circuited a lot of interactions, but in some ways Zoom has made it closer. Like you know, people show up at these meetings.
Yeah. And I see the slides.
Going backwards, sorry.
No problem. So you'll get a preview of my slides as we're backing through them. There we go. Thank you, Ann, for doing that. Again, Kevin Shafer. And MMSD is the regional sewer utility. We are not the drinking water utility. We just handle wastewater and stormwater. And I just love this picture that's on this cover slide because this is one of our Green Schools projects where this area used to be a paved surface, and we've gone in and naturalized the area. And you see these young kids just running through and enjoying it. It means so much to me to see a picture like that, because it really shows that social impact that what we do really has on neighborhoods. Next slide, please. So what does MMSD do? Well, we reclaim wastewater. We take the water that the drinking water utilities have pulled out of Lake Michigan. They've provided it to each of us in our homes. Anytime you flush a toilet, you do your laundry, do your dishes, take a shower, any type of water that's used in your home or business, it then goes into a sewer, comes down to MMSD, where we treat that water and we put it back into Lake Michigan. So it's a complete cycle for us with our water. We also manage flooding. This is a picture. I believe this is circa 2004, 2005 from the Thiensville area. So what we're trying to do is avoid floodwaters getting into people's basements, because in the basements are a floor drain, which then connects to the sewer system and overloads the sewer system. Next slide. Our service area basically goes from just north of Thiensville up to the north, down to the Racine County line on the south, from Lake Michigan over to the Subcontinental Divide. We do not service South Milwaukee. You see that little notch where South Milwaukee should be. They have their own wastewater treatment plant. But there's 28 different municipalities, 411 square miles. 18 of the municipalities are inside Milwaukee County and 10 are outside. And it's roughly 1.1 million people in the area. The red hatch that you see in the middle of the drawing is what's called a combined sewer system. So you heard Carol talk about how Jones Island's been operating since 1926. At that time, most of the area that it serviced was just a combined sewer, which is really just one pipe that carries both stormwater and wastewater. The rest of the area is a separate sewer system, which came along later in time. And a separate sewer is a pipe that just carries wastewater. And then you'll have a separate pipe that'll either carry stormwater or a ditch that carries stormwater. I live in Fox Point, where I'm at right now, and that is a separate sewer system. Next slide. So we've got these two pins on the map, and they show the location of the Jones Island Water Reclamation Facility and South Shore. Jones Island, again, came online in 1926. It can treat up to 390 million gallons a day of water. And it's the typical treatment process that's used throughout the United States, the same with South Shore. South Shore came online around 1966. It treats 300 million gallons a day during wet weather. So on a normal day like today, when we've really not had rain, each of these plants are treating about 75 million gallons a day each, but they can go up to 390 and to 300. So it's a very fast spike that occurs at these plants when we get a rainstorm. That's why I'm always watching the radar. Next slide. And although when we built the facilities, we thought of them as a wastewater treatment plant, they really are a resource recovery plant. We are pulling resources out of that wastewater and reusing it. Next slide. And that's just a great picture. Next slide, please. And this was the very first resource that we started pulling out of that wastewater. It's the biosolid product that we call Milwaukee Organic Nitrogen. Been producing this since 1926. And every treatment plant that treats wastewater, it goes through the 4 different steps to treat the wastewater. It's preliminary, primary, secondary, and disinfection. And through that process, you get cleaner water that you discharge back into the environment. And then you have biosolids. And a lot of places will take those biosolids and they'll either incinerate them or they'll just land apply them as they are, like a wet cake. Here in Milwaukee, we really revolutionized this back in the 20s, where we started heating those biosolids to a very high temperature, and then to kill the pathogens that are in there. And then we put it in a bag and we sell it on the open market. We last year sold over $11 million with Milorganite for a lawn fertilizer, and hopefully everyone buys that for your lawns. Next slide. Clean Water Act passed in 1972. And when that passed, my home state of Illinois filed a lawsuit against Milwaukee and the state of Wisconsin for overflows into the Great Lakes. It was the best lawsuit that could have occurred for the region. And when it occurred, we started what we called the Water Pollution Abatement Program, which is a huge construction effort to build a deep tunnel system. This is a picture during that original construction of the deep tunnel. And today we've got a tunnel that holds 521 million gallons of water. It's about 28.5 miles long and 17 to 32 feet in diameter. So if you take a rainstorm, and if we maxed out both treatment plants, we can treat 690 million gallons a day of water, plus store another 521 million gallons. So between all of this work, all of these improvements, we really have reduced the amount of overflow that gets, or the water that gets into the waterways. And an overflow is just an occurrence that when the system fills up, it can't take any more water. Then we have to put it somewhere so that it will try to prevent basement backups. And that's when we have an overflow to the waterways. Next slide. And as you can see, since the tunnel came online, it's captured and cleaned 98.4% of all the water that's come to it. So we do not have overflows a lot anymore. It's at 1.6%. And so far this year, we have had 0. Last year, we had 2 overflows. And one of those was the day when we had 5 inches of rain. And it's just almost impossible to catch a storm when you've had 5 inches of rain in 24 hours. You see places around the country that have these occurrences happening all the time. And we are one of the premier utilities in the country for our record to reduce overflows and having this high percentage of capture and clean. Next slide. So in 2009, I kind of hit this point in my career where I wasn't sure if I was going to survive or not. And I thought I was going to have to change the dynamic. So in 2009, I wrote what was called the Executive Director's 2035 Vision. And it basically said what you see here. It's really 2 halves of my brain. The left side of the brain is the integrated watershed management path, where I said we are close enough to it where we can get to 0 overflows, both sanitary and combined. We can have 0 homes in the 100-year floodplain through the flood management work that we do. And I want to stretch what we're doing by also expanding on a program that we call Greenseams, which I'll talk about in a minute, and start looking at ways to capture rainfall where it falls before it runs into the ground, before it gets into the pipes, and before it floods people downstream. So that's a goal of capturing a 1/2 inch of rainfall with something called green infrastructure. On the right side of my brain, it's the climate adaptation goals. Back in 2009, I was probably late coming to the game, but I realized then that we were already seeing climate change occur. And this was a serious effort serious impacts that we were seeing from about 2000. We've seen more intense storms hit the area and a lot larger volumes of water running off. So with this climate change hitting us, I wanted to also reduce our impacts on the climate. So I said that we were going to be 100% renewable energy by the year 2035, and 80% of that energy that we use would be internal resources that we would produce ourselves. And then we tried to sequester carbon with the Greenseams program. And in 2005, we created a carbon footprint, and we wanted to use that as the baseline and reduce our carbon footprint by 90%. So all of these things occurred in 2009, or the statement occurred in 2009. And in 2010, the commission came and they adopted this vision as the MMSD vision. So this is the vision for the district moving forward. And you'll see how we've been tracking towards that on some of these subsequent slides. Next slide, please, Ann. So on the climate resilience side, we've got a project called Landfill Gas Pipeline Project. There's a landfill called Emerald Park down in Muskego, and they approached us in 2008 and said that they produced enough landfill gas that they thought they could produce a significant amount of energy for the district. So we studied it for about 1.5 years, 2 years, and then started building a pipeline. And today we have a 19-mile pipeline that connects that landfill to the Jones Island Water Reclamation Facility. And they take the gas that comes off of that landfill, which is just part of landfill management. And instead of flaring it at the landfill, they clean that gas, pump it down to Jones Island, 19 miles. We take that gas and burn it in these generators that you see or turbines that you see in the upper right left-hand picture, burn that landfill gas instead of natural gas. And that reduces our overall climate or carbon footprint. And you'll see that at Jones Island, we're providing about 1/3 of our energy right now based on landfill gas and not natural gas or coal. At the South Shore plant, this is the bottom picture that you see. We have 8 digesters. I'm sorry, 8 digesters at South Shore. And we take the biosolids that come off the wastewater treatment process, place them in these digesters, allow them to stew there, and they produce methane gas. We capture that methane gas, clean it, put it into generators at South Shore, and we produce electricity on there. And we're about 55 to 60% of our energy production at South Shore is coming from this digester gas, which before we were just flaring off. So it's just a great way to reuse a resource that before we were just wasting into the environment. Next slide. We also have solar installations at the Jones Island plant and at headquarters. The upper left picture is on top of the dryer and dewatering building at Jones Island, and then the hot water solar panels on the right are at our lab building at the headquarters. Next slide. In 2004, 2005, we realized that we were seeing water quality problems occur when we were not having any overflows from the MMSD or local systems. And we started looking at this with the Southeast Wisconsin Regional Planning Commission. And in 2004, where it looked at the entire watershed. It did not stop at that red line, which is the sewer service area. It went through the entire watershed. So the orange is the Milwaukee River watershed, green is Menomonee, lower left purple is Root River, the blue is Oak Creek, and that bright purple is Kinnickinnic River. Looked at all these watersheds for pollution sources and modeled all types of land use. And what SewerPAC came out and said was that, you know, roughly 93% of the pollution that's still getting into the waterways is coming from stormwater runoff, both from urban setting and from agricultural setting. So not only do we need to do something about sanitary sewer overflows, we also really need to look at this runoff that's occurring off parking lots, rooftops, yards, and everything else. Next slide. So we've incorporated a lot of that information into our flood management program. And the upper right picture, I believe about 6 years ago, was a concrete line channel. Today, you would not know that that's the Underwood Creek project in the urban setting. You would think you're in northern Wisconsin. The picture on the left is the Valley Park project, which is a flood management facility right across the interstate from the Brewer Stadium. I forgot what they called it now. And then the Menomonee River is the lower picture, which is in downtown Wauwatosa. So we tore concrete out, we naturalized these areas, and tried to return nature to a very urban setting to really try to start addressing some of these pollution controls problems that we're seeing. Next slide. Here's the Menomonee River. This is near the Miller Brewery that we are done. We removed the concrete. So in the 1960s, we placed this beautiful concrete in here, and it did a terrible job of managing the hydrologic cycle. It cut off infiltration into the groundwater, and it increased the speed of the flow of water through this river to a point where we've had several deaths in the Milwaukee area for people being washed away from these high flows. So we want to get rid of these channels, not only for an environmental aesthetic reason, but also for a public safety reason. Next slide. And here's a great before and after. We just completed this project last summer. This is Pulaski Park on the Kinnickinnic River. The upper left picture is what it looked like before. Again, concrete line channels that we placed in the 1960s. And the lower right is that same area where we've gone in, worked very closely with Milwaukee County Parks. They've been a great partner on this. And we went in and basically rebuilt the park. We took the concrete out, we naturalized the waterway, but we didn't stop there. We also tried to bring back some of the social benefits for the neighborhood, tried to reduce impervious cover in the area, bring back recreation to the area. and just really try to make this an amenity for the neighborhood as opposed to just an ugly concrete channel that's flowing through a park. Next slide. So we've been doing wastewater treatment improvements every year. We're putting money into the plants, into the pump stations and so forth. We've been doing the flood management work where we're taking the concrete out. And so we slowly are working upstream. We started at the downstream end, working at the wastewater plants, working on flood management in the rivers. And now we're looking to start, we've been moving upstream. We've been doing this since 2002. This is green infrastructure, and we set a goal of 740 million gallons of green infrastructure. This is all based on that half-inch of rainfall that I talked about in the vision that we want to capture. So we called the program, thanks to Mayor Tom Barrett, the Fresh Coast 740. He started the Fresh Coast term. And it's the Fresh Coast 740, where we want to install 740 million gallons of green infrastructure on top of the 521 million gallons of tunnel storage, on top of the 690 million gallons per day of treatment of wastewater. All of these things are additive, and they're more on a watershed scale. Next slide. So we've got around 40 million gallons of green infrastructure. We set the goal of 740. So we've got a long way to go. We got 700 million gallons to go, but we've got till the year 2035. And if you're driving around and you see in this upper picture the black barrels, you might see rain barrels on homes that have downspouts, which all of us have. And on some buildings, you'll see green roofs, which is what you'll see in what that top picture is a picture of. And it's just a way to intercept that rainfall before it gets down into the sanitary system or before it runs off as stormwater collecting pollutants and maybe flooding people out downstream. Lower left picture is utilizing urban gardening to help absorb water as well. And the lower right is one of our green school projects where we're going in, trying to remove the asphalt coverings that we placed around schools so that we can provide our youth a more natural place to play and to have a healthier environment. Next slide. So here's the rain barrel program. I think we're over 4 million gallons now. Each rain barrel holds 55 gallons. And I tell people, if you have a rain barrel at one of your downspouts, it's like your own little tunnel. You get to manage water off your roof, just like we get to do with our 521 million gallons. But if you can store it there, you're preventing it from going downstream and causing a problem. Next slide. Here's some of the green roofs. Every time it rains, right now, we've got close to 500,000 gallons of storage on people's roofs. The upper right picture is the library downtown. Lower right is a development of a condo development. Yeah, that really is a green roof. Just very cool approaches to try to bring nature back to this urban setting. Next slide. So we tabulate all of this. We're the first utility in the country to ask for and have this green infrastructure placed in our permit, which is from the federal EPA and through the DNR at the state level. So we track this every year, add to it. And as you can see, it's hard to see the different categories, but we have a dashboard that we have bioswales, green roofs, that we track all the gallons that we're capturing by type and the money spent. Next slide. This is the Greenseams program. We started this back in 1998 to 1999. And this is part of our flood. We started this as part of our flood management initiative, where we wanted to reduce the amount of impervious cover upstream on the watersheds. If you remember that map of the watersheds, the Milwaukee, the Menomonee, try to reduce the impervious upstream areas, because that just forces that water downstream, higher volumes and very fast. So we initiated a land purchasing program called the Greenseams program, where we purchase land in a voluntary purchase. There's no condemnation. Purchase land, we put a conservation easement on that land, and we'll turn it over to different municipalities to manage as open space for recreation, or it's a land trust. McLellan Nature Preserve has a lot of land that we've provided to them as well. So we've gone through and we did that on a flood management approach. And again, it was 99, 2000 when we started that. But it was about 10 years later when we realized that this is a huge benefit to trying to be adaptive to a changing climate. So we started a tree planting program. We've got over 100,000 trees planted on this land. These trees are sequestering right now, we think, around 2,700 pounds of CO2 annually. And if you look at that against our emissions, that's 1.2% of our annual emissions. So we're starting to see these things add up together and have a real benefit to the region and to being more adaptive to the changing climate. Next slide. So that's it. You know, when I moved here, you never saw people on kayaks on the Milwaukee River downtown. You never saw the crowds that you see at Bradford Beach today. And we've really come full circle where now we understand this great water resource and the benefit that we have to it, but we also know that we need to protect it. So thank you so much for having me speak today, and I'll wait to watch Sandra's presentation.
Oh, I think Carol, you might be muted.
Sorry. I was so, no, you can hear me now, right? I was so impressed by all of the different projects and how many people these projects have touched around our community. All the children, the gardens, the green roofs, it's impressive. You can feel proud of what you have achieved. We will hold questions until after Sandra's talk. And then while she's talking, those of you in the audience can be thinking of questions and put them into the chat function. Sandra McLellan is a professor in the Human and Ecosystem Health Department, the School of Freshwater Sciences at UW-Milwaukee. Her work focuses on understanding the linkages between the environment and human health, particularly in urban coast systems. Her lab uses the microbiome signatures from animals and humans to identify pollution sources in water, and has developed approaches to investigate contamination in stormwater outfalls, rivers, and the causes of beach closing. More recently, she is analyzing wastewater samples at MMSD to understand the trends of COVID-19 in Wisconsin communities, and is partnering with researchers nationwide to implement surveillance programs that will provide data for a more informed public health response. We welcome Sandra McLellan.
Thanks so much for having me this evening. And I really appreciated Kevin's talk because it was really uplifting. And unfortunately, now we're going to turn back to the pandemic, which has been weighing all of us down for the last couple months. And let me just start my slides here. So my lab over the last year has just dove into using wastewater as a means to do surveillance in the community. And I'll get into some of the research and the methods that we've done and how it's kind of helped public health. But before I do that, I really want to thank all the people in my lab and my colleagues at SFS, because it really, what I'm going to talk about tonight was really a team effort. This started literally 1 year ago with just an idea, and two of my postdocs, Adelaide Rougeau and Shushen Feng, dove in and muscled through doing, lab work for late hours into the night. And then other people in the lab helped with the logistics, Deb Dila, Melinda, Jill McClary, one of my environmental engineer postdocs, and then a number of students just do a lot of the hands-on work. So without this whole group, none of the work that I'm going to talk about is possible. So as Carol kind of alluded to, my day job is not working with COVID. It's actually trying to figure out where pollution sources are coming from. And for the last 20 years, I've worked in the Milwaukee River Basin and around Lake Michigan, trying to understand when we detect E. coli, which is an indicator of fecal pollution, when we detect that in the water, where is it coming from? And we have many concerns in our community. Kevin mentioned stormwater. We have upstream agricultural runoff. We occasionally have combined sewer overflows. But another issue that we have is our pipes are old. We also see leaking infrastructure and leaking sanitary sewers. And what happens when it rains is the soil gets wet, the groundwater kind of rises a little bit, and it gets into our stormwater systems, and that's a 4-lane highway into Lake Michigan. So for a number of years, my lab has done microbiology to figure out, besides E. coli, which tells us nothing about where these sources are coming from, besides E. coli, what organisms can we follow? So we started sequencing all the organisms in sewage and other pollution sources like agricultural runoff. And then we would go into the waterways and try and track them. And we were really trying to get at these basic questions, you know, is there a health risk, and what can we do to mitigate the problem? But along the way, what we found is that within sewage, it's actually an integrated sample of the entire population. So we've also done some work looking at just the microbiome of humans. And we published a paper about 5-6 years ago showing that cities that have a higher obese population actually have different bacteria from humans in their sewage than cities that have healthier people and a leaner population. So there's a lot of work kind of nationwide that not only are we looking at sewage in terms of trying to track it in the environment, but also trying to understand maybe the health of the community. And that led to our work looking at the SARS-CoV-2 virus. That's the virus that causes COVID-19. And it's been reported that it's been shed in feces. So it enters the sewer system, not just through the feces and through people, but also through saliva, through brushing your teeth, through throwing tissues or Kleenex down into the wastewater system. So there's a number of different routes that this virus can get into the wastewater. Many of us remember back in the early days of the pandemic, probably end of February, March, where we were hearing things on the news and there wasn't a lot of testing available. So there was limited testing and we were really unsure about how widespread this virus was in the community. And we didn't know if this was a situation where if you had symptoms, we were really, that's where the COVID was, or were there asymptomatic people? And unfortunately, we have found that there are a lot of asymptomatic people, and it makes it very hard to understand the trends in the community because those asymptomatic people don't even know they're sick. So they're not going to get tested and they're not showing up in the statistics and the trends that public health follow. And why is that important? Because as the COVID spreads, we need more hospital capacity and we need to be prepared for the people who are going to get very sick. So in a public health sense, they want to know is this thing spreading like wildfire in my community, or are our mitigation and our lockdowns and our restrictions working, and is it dropping? And it's really hard to get a handle on that by just looking at the testing statistics. So a number of us that work in environmental microbiology and have worked with wastewater and sequencing sewage started talking to each other and said, maybe we should be testing the wastewater to look at the virus and try and quantify it there. And it was very much like the quote, my favorite quote from Louis Pasteur, chance favors a prepared mind. I don't think anybody outside of our field maybe thought about wastewater, but you bet all the environmental engineers that have done this for a number of years, as soon as we heard it was shed in feces, we thought this would be a great way to understand what's going on in the whole community. And I can almost pinpoint the day. I just submitted a grant and it was like February 4th, and this was just hitting the news. And I started sending a few text messages to my colleagues around the country. Again, other people working in environmental microbiology. And by the end of February, we had kind of formed this network. So even people that I didn't know, but I knew, through another contact, started getting together on Zoom and having these weekly calls to talk about ways that we can possibly track this in wastewater. And by March 11th, as we all know, a global pandemic was declared. And it became clear that this was going to be a big deal. Before that, I would say, many people, even people I know that work in the medical field, really weren't sure where this was going. Was this going to get contained? What was going to happen? I'm going to admit that I teach classes in like global pandemics and I lecture on this. And I was even taken aback by how quickly this virus spread. Being a respiratory virus, it's contagious, but it's very contagious. So it really was from getting on my radar screen in the end of January to March 11th, the entire world knew we were in trouble. The first report of somebody using wastewater to track COVID-19, the SARS-CoV-2 virus, was really out of the Netherlands by one of our colleagues, Gerten Medema. And he published a paper in Nature showing that it was somewhat of an early warning, that they could detect it in wastewater before they really could detect it in the community. Again, this is early in the pandemic where there wasn't a lot of testing. And then around the United States, a lot of my colleagues, the ones that have been, communicating back and forth, really started a lot of different efforts. Allie Boehm, one of my close colleagues at Stanford, and Krista Wigington together started sampling almost 50 wastewater treatment plants, not looking at the treatment plant influent, but rather the primary solids further down in the process. And then Utah was sampling wastewater and actually was one of the first states to launch a public dashboard. Colleagues out at Hampton Roads Sanitary District did a lot of the early work to figure out how to do some of the sampling and the filtering I'm going to talk about. And then my colleague in New York City, it started a program looking at 14 wastewater treatment plants. And I'll talk a little bit about that. And then there was a lot in the news about how some of my colleagues at University of Arizona actually were monitoring dormitories and found the SARS-CoV-2 virus in the wastewater from the dormitory, went in and tested, found those students and was able to isolate them. So I want to talk briefly about two projects that we've been involved in to really get the surveillance program going. And the first one is kind of a national effort with the same group that has been communicating since February of last year. We were fortunate enough to get a grant from the Alfred P. Sloan Foundation, and it funds myself, Andrea Silverman, Allie Boehm, Kyle Bibby, and also a life sciences communication professor at UW-Madison. The project has two objectives. One is to work with New York City to build capacity. As you all recall, it was the first city to be hit hard, and it was really a tragedy. The second objective is really to bring together kind of this national expertise and develop a communication strategy, because we're all environmental microbiologists and environmental engineers generating data, but how do we communicate this to public health? How do we make it useful for them to be able to respond to the pandemic? So I mentioned Andrea Silverman. She really spearheaded that first objective in New York, and New York City has 14 different wastewater treatment plants. So they handle more than 1 billion gallons of wastewater. And it's interesting because you could see differences around New York City in terms of the concentration of SARS-CoV-2. So that allowed the city to understand where the hotspots are. And she worked with their Department of Environment, which is their wastewater agency, to implement these methods in their laboratory. So now they're running a full program. And then the second objective really was to do this communication network. And as these researchers met, it became apparent that there wasn't one single method that would work for wastewater. It was obvious that we all had to try diverse methods to almost crowdsource optimizing what would work. And it came down to understanding that proper controls in all of these methods were really the key so we could compare them. So our project has a website and it's hosted at UWM. The acronym is CoSeS, Communicating Sewage Surveillance for COVID-19. And this website is not necessarily geared for the public. It's geared for public health. It's a resource for public health departments, either at the county or city or municipality level, to get information about using this in their own community. Okay, the second project I'm going to talk about is our large surveillance program in the state of Wisconsin. And this was a partnership between my lab and the Wisconsin State Lab of Hygiene, and it's funded by the Department of Health Services. And I really have to give John Myman, one of our chief medical officers, a lot of credit for really buying into this early. And we were able to jumpstart this and get this going by this summer. So my lab is monitoring the densest part of the state. We have 12 service areas and it covers about 1.8 million people. And we sample those plants quite often. And then the State Lab of Hygiene is really doing the heavy lifting. They're sampling another 60 wastewater treatment plants, anywhere between once a week or every other week on a rotating basis, and then some also twice a week. So I just want to talk a few minutes about the technicalities of this, because when I say it was really hard to get it up and running, it really was from square one. And there were three main things that we had to figure out. First, what's the precision in the measurements? You can't generate data that's going to be useful for decision making if you don't know how reliable is it. You know, if I take two samples in a row, will the measurements be precise? So we put a lot of work into that. And then how often should we sample? These samples are not cheap to do. So running a sampling program, we had to figure out how to design it. And then the ultimate question is, does what we see in wastewater reflect the pandemic that we see in the community? Okay, so I just want to cover a little bit about the methods. This is kind of the sampling and method overview. There's 24-hour flow-weighted samples collected at the wastewater treatment plant already. So many wastewater treatment plants have laboratories. They're collecting these samples for regulatory purposes. So for us, it's a matter of picking up a bottle at the laboratory. So that part was easy. And then the next three steps involve processing the sample to concentrate the virus, and then we extract the RNA, and then we quantitate it with ddPCR. And that stands for digital droplet PCR. So the first step, like I said, is easy. And the second two steps are exactly what happens when you get a clinical test for COVID. They essentially take a swab, they extract RNA, and then they quantify the virus by either qPCR or ddPCR. It's this concentration process that is tricky and took a lot of time to figure out. But after a few months, we were able, and thousands of samples, we were able to optimize that method. And then the next question is how often we should we sample? Milwaukee was almost the ideal place to try and figure this out. As Kevin covered, there are two main service areas: the South Shore service area that goes to the South Shore wastewater treatment plant, and then the Jones Island service area. And because one is nested within the other, kind of the clinical case trends are about the same between those two service areas. So we were actually able to do biological duplicates. We could sample 2 days in a row at each wastewater treatment plant, and then we could compare Jones Island to South Shore, and you can see they followed the same trend. And then in September, we did some really intensive sampling while trends were going upward. And then we could statistically figure out the best days to sample, which turned out to be 2 days spread out in the week and now we sample Mondays and Thursdays. So this is what our workflow actually looks like. And it looks really complicated because it is. Usually in a research lab, we collect samples for a few weeks, we process the RNA, and then we get results, a few weeks later, and we think about it. In this case, we get a sample, samples are collected Sunday to Monday in this case. They're shipped to us, and between Tuesday and Thursday, we have to process the sample, quantify it, do all of the controls, interpret the data, put it in the computer, and then we report it to the Wisconsin Department of Health Services, who in turn sends the data to the CDC. And then we do it all over again in the second half of the week. So it's a really different mode of operation for a research lab, but all of those people that I mentioned in the beginning have really stepped up to make this workflow work. And then finally, what does this, does the wastewater measurements reflect what's happening in the community? So the data we generated is now on a public dashboard, and you can find it real easily by going to the Department of Health Services, and you can just Google wastewater and COVID-19, and you'll get the main page, but I'll share that link in a bit. This is the data that's on the dashboard since we implemented the program in the end of August, and you can see the top panel here are our wastewater measurements. And you can see the spike we had in November around Thanksgiving. You see the drop in January. And right now in March, you can see we are doing as well as we were in the beginning of September. And then in the bottom panel are the actual clinical cases. And you can see that the wastewater has mirrored the clinical cases really well. The same thing is true for Jones Island. So this is Jones Island, and you can see the concentrations are not as dramatic because they're a little bit more dilute. Kevin mentioned it's a combined sewer system, so that makes the actual measurements more dilute, but they still track very closely with the clinical cases. We also sample Racine, and again, we find that there's a very good correlation to the clinical cases in the community. And then Green Bay. And I want to point out that Green Bay's clinical cases spiked much earlier than Milwaukee. Already in October, we were seeing warning signs, and we were actually sampling much more intensely because of it. And you can see how high those spikes went up in wastewater, and they weren't necessarily captured in the clinical testing. And this again might suggest that that clinical testing just wasn't keeping up with the number of cases. So this is the website for the Wisconsin Department of Health Services that you can find all the information that I just showed you. We report our data twice a week. So from the time we get to the sample to the time it's showing up on the dashboard is about 36 to 72 hours. Okay, so in conclusion, we really have found that wastewater is a great way to monitor SARS-CoV-2 in the community. And it's been useful to track it with the clinical testing that's going on, because now people are there's starting to be testing fatigue with vaccination. Testing is starting to go down. So now we have a way to do surveillance in case any of those variants crop up. And that's the next thing we're working on. We're specifically looking for those variants in the sewage samples. And then because of our kind of optimized method, it's very sensitive. So we feel like it's going to capture if there is a problem early on. We found that we were able to detect the SARS-CoV-2 virus when there were 9 cases per 100,000 in the wastewater. And that, I mean, that is just really sensitive. Now, does that mean there's actually 9 cases? No, there's probably 90 or 900. We have no idea how much underreporting and under testing is going on. So as I wrap up, I just want to give a quick public service message on these variants, because it is the thing I am very worried about. Viruses naturally mutate, and they mutate really rapidly. And you ask, why is that? Well, it's because every time you're infected with the virus, they're making 1 trillion copies that are being sneezed and blown out into the air. So it's really easy to get mutations. So trillions of viruses are made, and it's easy then for the next person to catch one of these mutants. This is just a kind of a phylogenetic tree of all the mutations that have happened since January. Down in the corner in the purple is the original Wuhan strain, and you can see the red, orange, and kind of light orange here are the UK variant, the Brazil variant, and the South African variant. So it really didn't take long for these variants to develop, and each dot here is a patient that's been sequenced. So it's really very prominent in the UK, and we're starting to see it here in Wisconsin also. So what does that mean for the vaccination? The bottom line is we really have to stop the spread of COVID so it doesn't have a chance to keep mutating. People want to let their guard down. We feel like we're out of the woods, but kind of in the words of Anthony Fauci, if viruses they can't mutate if they don't replicate. So if we can keep minimizing the spread, we're minimizing the chance that a mutant is made that can actually get past the vaccine. So it's almost a race to try and wipe out or minimize COVID before there's a mutation that our immune system just can't handle. So what can you do? You can wear a mask, you can wash your hands, you can get vaccinated. But one of the more important things is think like a microbiologist. And when you're thinking about different activities, I'm one to believe, we don't need to lock down and wait for this to go by, but we need to be very reasonable and diligent about stopping the spread. So I'm going to end with that. And I just really want to thank everybody again in my laboratory that's worked with this, including Angela Schmoldt, who's in the Great Lakes Genomics Center, and then the group out at the Wisconsin State Lab of Hygiene that, again, they're doing the heavy lifting on 60 of the wastewater treatment plants, John Myman and Nathan Klotzko. And then all of our funding sources, funding from UWM, Office of the Chancellor, and the School of Freshwater Sciences really got this kick-started. In science, they don't just give you a credit card unless you order $10,000 of reagents to try something. So our school really backed this early work. And then the Department of Health Services, the Alfred P. Sloan Foundation, and of course, MMSD through their student fellowships, and also early on in-kind sampling that allowed us to do those, that early optimization. While everybody was shutting down, Kevin probably remembers his phone call in March. It was like the second week in March. I'm like, but Kevin, we need more samples. Can we get samples? And they've really worked with us to get that up and going. So I'm going to end with that and turn it back over to Carol to moderate some questions.
And if I could, before Carol comes on, I do remember that phone call. And I just, on that Saturday, the 14th of March, I had sent my staff home. I said, don't come to work on Monday. We're going to start working from home remotely. So I go into the office Monday to try to get all this stuff going and coordinate everything. And my phone rings and it's Sandra. And I'm like, what? You want to sample our poop? Okay.
Yeah, I need extra samples. I don't just need the normal samples.
Right.
I need extra samples.
Yep.
Yeah. So it was a good partnership.
It always has been. Yeah.
Wonderful. One question I have for you, Sandra, you mentioned, I think early on, that your original sample is from the primary clarifier.
Yeah, actually, that's some work my colleagues is doing. Because it's an enveloped virus, it actually absorbs onto solids. So they are looking at primary clarifier solids to see if it's more sensitive. Because when you are trying to kind of isolate it and concentrate it out of influent, it's really difficult. Whereas the primary clarifier solids might be a way that naturally concentrates it. So once we see COVID get no longer detectable in the influent, we are going to try those methods, because it doesn't mean it's gone from the community. We still need to do surveillance.
Very interesting. Let's take questions from the audience. The first one, is there a lag time between when people experience symptoms and virus shows up in sewage?
That's a great question. And a lot of people are trying to figure that out. But looking at the data, especially around Thanksgiving time, where people were being tested and they were asymptomatic, but they were being tested because they wanted to travel, we do see that it's almost the same timing. So people wonder, is this an early warning? Not really if there's a lot of testing, because the testing in Wisconsin is turned around within 2 days. And now it's reported within 2 days and you get your result on the spot. However, in some states, it's still taking 2 weeks to get testing results. And early on, there was a delay in the testing results. So public health wanted to know what was going on when kind of testing was delayed. But where this is going to be really useful is when testing drops off. Now it's a way to keep an eye on the whole community without asking the whole community to constantly be tested.
Okay. Milorganite is produced down at Jones Island. If there's COVID in sewage, does using this fertilizer then spread in its use?
Oh, can I answer that one? I know Kevin wanted to. I would,
We'll give him a chance.
Yeah, well, let me just jump in. There was a lot of work within the wastewater agencies out in California and a number of different places, just trying to understand if there could be a health risk to workers, and no viable virus has been isolated. So it's only a tracer. It's no longer viable. And a respiratory virus is pretty wimpy in the environment. So by the time it hits the environment of the wastewater system and goes through treatment, it just doesn't stand a chance.
Kevin, you had a comment?
She answered it. There's been a lot of research on this around different utilities around the country with their biosolids. And we've done some sampling and testing of our Milorganite product as well. And it verifies what Sandra just said. We're just not seeing it survive through that.
Okay. Do you have any indication that variants are here now?
Yes, we work closely with the clinical lab at the Wisconsin State Lab of Hygiene, and they have detected the UK variant. It's also in Minnesota. And there's a lot of communication right now with our lab and the State Lab of Hygiene, trying to get the test that specifically detects the UK variant up and running. And we hope to do that next week. So just when we get our workflow done and we feel like we can relax, these variants have kind of reared their ugly head. So that's kept us pretty busy the last few weeks. What we hope to do is not just test for the SARS-CoV-2, but specifically be able to detect if UK variant or the South African variant is in the community. We expect that we're going to see it first in the clinical labs, because clinical labs are sequencing, their samples, but they'll have no idea how widespread it is. And that's where the wastewater surveillance really comes in handy.
Okay, thank you. From your perspective, and I think this is for Kevin, what are the most urgent water issues that need to be addressed by the EPA in this current administration? What kind of regulations or actions would you like to see at the federal level?
Yeah, well, the hot topic right now is the forever pollutants, the PFAS, PFOA pollutants that are out there. We're just now starting to understand the impacts that those have, and just how we can test for them and understand how to manage them better. So I think there already is, and there will be a lot more policy work around the forever chemicals and trying to manage them better. So that's more of it's actually something that's very active in the research world right now. We need to be more cognizant of the impacts of agricultural runoff and urban stormwater runoff on our water quality. Sandra opened my eyes to this back in 2003. We had beaches that were closing along the lakefront, and everyone was saying it was human sewage that was causing that. Sandra went out and did DNA typing on the actual water where beach closings were occurring, and found out that it was coming from waterfowl, from birds. And so just having that science to help push the discussion further, I think taking that same type of approach with agricultural runoff will help us to better understand where that pollutant is coming from and then what we can do with that. So I think it's PFAS, it's looking at non-point runoff, stormwater runoff from urban and ag areas, and climate change. That's the thing that keeps me awake at night. I mean, we're seeing it, and it's something that we're just got to do more to address.
I'll follow that up with what are some of the ways MMSD is planning for climate change, and the kinds of reports that you are generating? What are you looking at?
Sure. We've got a climate adaptation program where we're trying to expand on our green infrastructure to try to bring more nature into the urban setting, reduce the heat island impacts. The green roofs themselves help reduce the energy usage on the buildings that are using energy. The planting of trees on Greenseams, so a variety of initiatives. And we're also starting to prioritize our projects in some of the more urban impervious areas where there's maybe lower income areas, and trying to place this green infrastructure in these areas to, again, address climate change, reduce stormwater runoff and the pollutants that run off, but also bring back some of the natural benefits of nature to this community.
Okay, wonderful. Sandra, is anyone testing our marine life for COVID? For example, freshwater fish and the resulting consumption.
You know, because viruses are so host specific, it's unlikely they'll make it into the food chain. There is some concern with like household pets and that have close contact with humans, and some animals like minks have been found to be infected with COVID, but not anything further afield in terms of animals like fish or other parts of the food chain. And then again, this virus is really meant to go person to person. And once it's outside of the respiratory tract, it just doesn't survive very long.
Okay. Are there any incentives for developers to install green roofs? And that's for Kevin.
There actually are. We have a program called the Green Infrastructure Partnership Program. We put out an RFP late January, February every year. Developers, building owners can put in a proposal to install a green roof on their buildings, and then we review those, and then we pay for part of that cost.
Okay. Are there other questions? One that I have, again, for Kevin, why is MMSD investing in watershed improvements outside of Milwaukee?
Well, if you look at the map on the biggest watershed, the Milwaukee River Basin, we are on the downstream end of that watershed. And that water flows into Lake Michigan, which is our drinking water supply. So anything that we can do on a watershed scale will help us protect our drinking water supply. And we also know that there's a lot of things we need to do in the watershed to improve water quality, but there's only limited dollars to do that work. And you can make more of you have a bigger bang for the buck in a lot of cases when you make improvements in the upper watersheds than going into a wastewater treatment plant and adding some piece of infrastructure. So you really want to look at the watershed as a whole so that you can optimize the reduction of pollutants at the minimum cost.
Wonderful comments from in the chat tonight, thanking both of you for wonderful presentations and so important to our community. We have great appreciation for your giving your time and expertise to come here tonight. One more question. Infrastructure needs that should be included in the federal infrastructure legislation. That's a great question.
Everything.
And you know, can I put a plug in for the CDC has they have started a program for this wastewater surveillance, and I feel like the biological infrastructure part of it and the the opportunity to do a pandemic observatory is really key. And it's really not just the bricks and mortar and pipes. It is the agencies working together and having public health work more closely with the wastewater agencies that's going to make that possible. So I think we need the intellectual infrastructure also.
And it sounds like the microbiological infrastructure, which we really don't know as much about, the connection. So thank you very much. Are there any, Kevin?
Well, I was being a little funny when I said everything, but I really think we need to concentrate that infrastructure bill, and the president's talked about it, build back better. And we really need to look at better ways to have multiple benefits for those dollars that we spend. And Sandra's exactly right. I mean, we don't do anything at MMSD unless we have a good scientific reason to do it or good research to show us how to do that. So you really need to connect those dots by just not, throwing money at a new pump station or pipes. We really need to look at these issues as a whole, have good science to report off of, and then go out and try to improve the community as a whole and not just look at certain pieces.
Well said. Thank you. Thank you so very much, both of you, for coming and speaking tonight. And thank you to my colleagues at the League of Women Voters, Peggy Creer, Ann Batiza, Louise Petering, the president of the State League, and all of the League members in the audience. And thank you to the audience and for your wonderful questions. And I think we will, unless there are other questions, there may be.
I was wondering, Carol, are there any closing remarks from our two speakers?
Yes. Sandra? Closing remarks?
I think I covered most everything, but I just want to kind of underscore how promising this new technique is, but it's very new. I mean, we literally just started it 12 months ago. And when you look at some of the age-old testing, it's been going on for 10, 20 years. So I think it's a very promising tool. And I think as we do research, it's going to become kind of a mainstay public health tool.
Okay, wonderful. Kevin?
I think what I would say is everything that you've heard us talk about today, individual people have a huge impact on. Sandra talked about, staying 6 feet away, wearing a mask, getting vaccinated. Those are all personal things that you can do to protect others. When it comes to water infrastructure, wastewater, just be conscious of the amount of water that you use in your home. Look to replace appliances with lower water users. Don't let the hose run down your lawn all day long, which some of my neighbors do. I mean, there's just simple things. Pick up dog poop. There's just simple things that people can do. And those simple steps add up and make a big difference.
Okay, thank you. And we will finish with a slide or two about the project that the League of Women Voters is working on with the American Society of Civil Engineers. The League of Women Voters of Wisconsin, American Society of Civil Engineers, Wisconsin section, are involved in offering meetings around the state. We've had two overview meetings. The ASCE produced the 2020 Wisconsin Infrastructure Report Card, where they graded 13 different categories of infrastructure. And this slide shows the grade. And everyone is welcomed to attend these meetings. You'll hear Carl Sutter giving an overview of the Infrastructure Report Card for Wisconsin, and William Holohan, a UW-M retired professor of economics. And again, we offer Q&A. People are free to ask questions, which we all get to hear the answers to. And starting on May 6th, we are going to offer individual category meetings or pairs of category meetings. And if you're interested, we welcome you to any or all of these meetings to get a more in-depth understanding of what are the issues in energy, bridges, roads, transit, and so on. It's a timely subject. Today, President Biden had an introduction to infrastructure, and there will be more coming on that subject tomorrow. So we thank you very much to our speakers and all of you for attending tonight. Thank you.
Thank you.